5.6, inverse of a function. So we're going to find the inverse of a linear function. Find the inverse of f of x equals 3x minus 1. Now to find the inverse of any function, we'll write the steps. So step 1 is we want to change f of x to y. Change the f of x to y. So we're changing this f of x here to y. F of x is y. So y equals 3x minus 1. Step 2, we're going to switch the roles of x and y. Switch the roles of x and y. So now the y becomes the x equals 3 times y minus 1. Then step 3, we're going to now solve for y. So first, we want to add 1 to both sides. So we have x plus 1 equals 3y. Divide by 3. So now we have y equals x plus 1 over 3. Our last step is to write the inverse of f, write the inverse of f as g of x. So we're just going to change this y to g of x equals x plus 1 over 3. And that's just how our textbook talks about it, g of x. You may also see this as f, an apostrophe, which is prime, of x. That's another way to notate it, and sometimes it's also written as y prime as well. Again, in our book, we will just write it as g of x. So now you're going to try 2 examples. Find the inverse algebraically for each of these linear functions. So trying this out, for the first example, you should have g of x equals 1/2 of x. If you left it as x over 2, that's okay. So we change f of x to y, switch the roles of x and y, divide by 2 to isolate the y, and notice we get x over 2 equals y. And so one reason why I want to write it in this format instead is just to remind us that this is the slope of this line. Number 2, you change f of x to y, switch the roles, then you add 2 to both sides. We get x plus 2 equals 1/3 y. Now in order to get rid of that 1/3, we're going to multiply by 3 to both sides. Now it's really, really important when you do that is that you put parentheses here because you're multiplying it to the entire thing. So the most common error students make is that they write 3 and then x plus 2, and then they forget to distribute it, right? So you need to balance the equation by multiplying it to every single term. So it becomes 3x plus 6 equals y. So again, you multiply by 3 just to cancel out the 1/3. And then so we have g of x equals 3x plus 6. Now we're going to find the inverse of a quadratic function. Now here it tells us x has to be greater than or equal to 0. So it's kind of telling us a restriction here. And so let me talk about that as we start to solve this example. Why is it greater than or equal to 0? So this is the same exact steps, right, as we did before. So the very first step is change f of x to y. So y equals x squared. Then we switch the roles of x and y. So x equals y to the square. So notice the square doesn't change. Numbers that are attached to the x previously doesn't go away. It still stays. So we have x equals y squared. Now we're trying to solve for y. So what we're going to do is we're going to square root both sides. Now remember, when we square root, we always take the positive and negative. Now this is telling us up here the x is greater than or equal to 0 is that we only want the positive. So we don't need to write plus or minus. It just says just take the positive of it. And so it's positive square root of x. And that cancels out that y squared here. So we have square root of x equals y, or we can write it as g of x equals the square root of x. So here's one to try. Try example 3. It's still x is greater than or equal to 0, so we're just going to take the positive when you take the square root. Pause the video and try it out. So if you tried this out, you would get g of x equals the square root of x plus 2. So again, you change the f of x to y, switch the roles of x and y, add 2 to both sides. Then to get rid of the square, you square root both sides. And so it's the whole thing, x plus 2. So then we have y equals the square root of x plus 2, or g of x equals the square root of x plus 2. So now let's try finding the inverse of a cubic function. So find the inverse of 2x cubed plus 1. So we're going to change f of x to y. Then we're going to switch the roles of x and y. So we have x equals 2y cubed plus 1. Then we're going to isolate our y cubed so we can solve. So let's subtract 1 from both sides. X minus 1 equals 2y cubed. And then now we want to divide by 2. So we have x minus 1 over 2 equals y cubed. Now in order to get rid of that cube, we're going to cube root both sides. Cube root both sides. And then, so now that is gone. And now we're looking at y equals the cube root of x minus 1 over 2. And we're not going to rationalize the denominator. We'll leave it as it is. Of course, the last thing we should do is write it as g of x. So g of x equals cube root of x minus 1 over 2. So try these two examples here. Pause the video and try it out. Okay, if you try these examples out, for number 4, you would get g of x equals the cube root of x plus 2 over 3. Then for number 5, you would get g of x equals cube root of negative x plus 4. So that one's a little different, so let me walk through that one real quick. So we change f of x to y, switch the roles, subtract 4 from both sides. Then you have negative y cubed equals x minus 4. So we want that y cubed to be positive, so we're going to divide by negative and a negative 1 in order to get rid of it so it's positive. So that makes it a negative x plus 4. Then you cube root both sides to get rid of that y, the cube for the y. And now it's just cube root of negative x plus 4. Last, let's find the inverse of a radical function. Find the inverse of f of x equals 2 square root of x minus 3. So change f of x to y. Then we switch the roles of x and y. And then we want to be able to isolate the y, or the square root. So let's first divide by 2. So now we have x over 2 equals the square root of y minus 3. Now to get rid of that square root, remember we're going to square both sides. Now be careful, you actually need to square the whole thing. So that's x squared over 2 squared, x squared over 2 squared. And this cancels. So we're really looking at x squared over 4 equals y minus 3. And then we want to add 3 to both sides. So now this is g of x equals x squared over 4 plus 3. Or we can write it, so we can take that 1/4 out. So 1/4 x squared plus 3. So then maybe you kind of see that's a vertical shrink by 1/4. And then up 3. Now one more thing that we have to add to this is that in order for it to be inverse, there's a little bit with the graphing involved with this. So x minus 3, it's actually shifted right 3, and so that's generally the shape. Now everything that is an inverse is going to be reflected across this line of reflection. Now we haven't talked about graphs yet. Everything needs to be reflected across that line. They should be mirror images. Now if we're looking at our parabola, so remember that's a parabola that looks like a U is shifted up 3. So looking at the radical here, that the radical and the parabola, they're not exactly mirrored. So in order to make them mirrored, we have to restrict it to only the positive. Another reason, or another way we can tell that it's positive is that the front number here is also positive. So if you can, you really need to add also that x has to be greater than or equal to 0. So if you were to try to find the inverse of the g of x, you would get the f of x. We need to remember that we only take the positive side. It's just like what we did over here when they had the restriction for us. X is always greater than or equal to 0. So for the parabolas, we need to be able to restrict it so that way it would be a good mirror image of our radical graph here. So try these two examples here. Try example 6 and example 7. All right, if you tried this out, the first example was just like the one on the left. You would get x squared over 9 minus 4, or you could write 1 over 9 x squared minus 4 is the g of x, and then just say that x has to be greater than or equal to 0. For number 7, we square both sides after we change y, f of x to y, switch the roles, we square both sides. Then we have x squared equals y plus 2. Then we find that we have g of x equals x squared minus 2. And again, just taking the positive, x is greater than or equal to 0.